Hello everyone, welcome to this video. I hope you are having a good day wherever you may be. In today's video we will be going over circuit analysis and electrical engineering. We will be going over the basics, and in future videos the plan is to go over topics such as Kirchhoff's current law and Kirchhoff's voltage law. But in order to understand those topics fully, we will need to go over some terms today to truly understand how to do those topics in the future. So we will be going over three things today, and those are branches, nodes, and loops. So you may have heard of these terms before, you may have not. Either way is okay. So the first one that we will go over are branches. So a branch essentially represents a single element or a component in a circuit. So I will write this down. So what I mean by a single element or component in a circuit, I'll go ahead and draw out a couple. So we can refer to a branch as, let's say, a voltage source. We could say a battery, which is essentially the same thing as a voltage source. We also have resistors, inductors, capacitors, current sources, and dependent voltage and current sources also, to name a few. And you will see these along your circuit analysis classes. And now we'll go ahead and move on to what are nodes. So a node essentially is a point of connection between two or more branches. Just like the last one, I'll go ahead and draw a few examples here so we can fully understand what that means. So I will draw a voltage source. As a reminder, this is a branch. We'll go ahead and have a wire connect this to a resistor. And I'm not going to draw anything else, we'll just focus on this for now. So I will go ahead and change my pen to the blue color, and I will go ahead and circle this part. So the circled portion, that is our node, because, let me highlight this portion, the red will represent the branches. So I'll go ahead and highlight our branches here in the small circuit example that we have. So as we can see from the definition up above, how it says a point of connection between two or more branches, well, we have this connection between two branches where the blue connects the two. So we can identify this blue portion as the node. I can go ahead and draw an example here where we can reference more branches than two. So let's say we have this example of a resistor connected with this resistor connected with this resistor. So this example looks a little bit more complicated. We will go ahead and label our branches in red once again. So we have 1, 2, 3 branches. And now we need to find where the node is. So our node is the point of connection between these 3 branches, which is in the middle here. So I'll go ahead and circle that part. So we can see from this example that a node is just simply a wire that connects to 2 or more branches. And now for the final term that we have today, it's a loop. So a loop is any closed path in a circuit. So this one, we'll go ahead and do some examples for you to fully understand it. It's kind of hard to understand just from the definition, I think. So let's go ahead and jump right into an example here that I have prepared. So in this example, we will determine the number of branches nodes, and loops. Now I'll go ahead and draw the circuit I have prepared here. And we also have a current source here. Alright, I'm going to go ahead and label these with some values. So our current source will be 2 amps. This resistor will be 6 ohms. This resistor will be 5 ohms, and our voltage source is 10 volts. So first we will determine the number of branches that we have. So I will whip out the red highlighter once again. So we can see here from above that these are some of the labels of branches that we have in a circuit. These are the components, and we can see, well, we have a voltage source, that's a component. So this is branch number 1. We see we have a resistor here, and we can reference this from the example up here. So we'll go ahead and label that, so this is branch number 2. Here's another resistor, so that's branch number 3. And here's a current source, which is branch number 4. So these are the 4 components of the circuit. Now, we will be labeling the nodes of the circuit. So remember, we have the definition up here, which is essentially a point of connection between 2 or more branches. So we will go ahead and do that. So I have my blue pen here. We will label all the connections between 2 branches or more. So here's our first one, which is between the voltage source and the 5 ohm resistor. I see another one here. This node is from the 5 ohm resistor, connects to the 6 ohm resistor and the 2 amp current source. And then at the bottom of the circuit there is another node, which connects the 10 volts, 6 ohms, and 2 amps all together. And I'll go ahead and change this to a blue highlighter and highlight the nodes, so we can get a better visual of that. So we have our branches and nodes labeled, and now the last step left is to identify all the loops in the circuit. So a loop, like the definition says right here, is any closed path in a circuit. So for example, this one is a closed path, so I'll call this L1, which means loop 1. Well, we see that there's another closed path beside the one we just made, which we will call loop 2, or L2 for short. And you may think that that is it because there's no more closed paths in the circuit. But actually there is one more loop that we can see, and that is on the outside of the circuit. So this will be our loop 3. And when it comes to loops, branches, and nodes in general, it takes a little bit of practice to identify them. So after this video, I would recommend that you find some practice problems to simply just identify the branches, nodes, and loops in a circuit. But now, since we have these things labeled, we now can see that, well, we have 1, 2, 3, 4 branches. We have, let's see, 1, 2, 3 nodes. And we have 3 loops. So we just identified all the branches, nodes, and loops in the circuit. And we'll go ahead and do another example here. And the purpose will be to determine the number of branches, nodes, and loops once again. So I won't write all those directions once again. Now we'll start with the resistor on this side. A resistor here. We'll have a resistor on top, a voltage source, and a resistor here. So I'm going to go ahead and put values for each component here. So we'll make this 1 ohm, 2 ohms, 5 ohms, 10 volts, and 4 ohms. So just like last time, we'll go ahead and start labeling things. Here I have my red highlighter to label all the components or branches of the circuit. So we know from the previous example that resistors and voltage sources are branches of a circuit. They are components, so we'll label those. So we have the 1 ohm resistor here, 2 ohm resistor, 5 ohm resistor, 10 volts, and 4 ohms. So counting those, we can see that we have 1, 2, 3, 4, 5 branches. So we'll go ahead and write that. Now, we will go ahead and label the nodes of the circuit. So once again, the node is a point of connection between two or more branches. So we can see here where the blue dot is, this is our first node because it connects the 1 ohm resistor, 2 ohm resistor, and 5 ohm resistor together. Our next node connects the 5 ohm resistor with the 10 volt voltage supply and the 4 ohm resistor. And our last node is at the bottom here where it connects the 1 ohm, 2 ohm, 4 ohm resistors and the 10 voltage voltage source. So we will go ahead and label those in blue for a better visual. So now we know that we have 3 nodes. So now we need to identify the loops of the circuit. So this one's a little bit more tricky because up here there's only 2 loops that looked identifiable, but here we have 3 obvious loops, so we will go ahead and label those. So we'll call this L1 like last time, L2, and L3. So, like last time, we found the tricky one where there is a loop on the outside, which we can go ahead and label again. So this can be our loop 4. Now, another tricky part, unlike this last one, we actually have 2 more loops. I will go ahead and give you a second to pause the video and try to find those 2 extra loops. Okay, let's see if you're able to get the 2 extra loops. So the 2 extra loops are actually hidden within these. So we have a loop from this one over to this one. So this will be our loop 5. And to put this into perspective, this goes from the 1 ohm resistor to the 5 ohm resistor to the 10 volts voltage supply. And then it returns. And then, just like loop 5, these 2 connect. So this is our L6 or loop 6. So we can say that the 4 ohm resistor connects to the 2 ohm and 5 ohm resistor, and that's it. So to put down in perspective, I will go ahead and write a list of the components here of where it all connects. So loop 1, we have the 1 ohm resistor to the 2 ohm resistor. Loop 2 is the 2 ohm resistor to the 5 ohm resistor to the 10 volts voltage supply. Our third loop is the 10 volts to the 4 ohm resistor. Our loop 4, that would be the 1 ohm resistor to the 5 ohm resistor to the 4 ohm resistor. And now for the tricky ones, we have the loop 5. So this starts at the 1 ohm resistor, goes to the 5 ohm resistor, and then to the 10 volts. Let me move these up here real quick so we can see the circuit better. And now for loop 6, we can go ahead and label that. So we can start at the 4 ohms, then that goes to the 2 ohms, and then that goes to the 5 ohms. So now we have identified all the branches, nodes, and loops of the circuit, and as we stated already, we have 5 branches identified, 3 nodes, and 6 loops. I hope this was able to help you identify branches, nodes, and loops. Like I said a little bit earlier in the video, I encourage you to look up practice examples online to be able to help you identify the branches, nodes, and loops of a circuit. This will help you for future fundamental concepts of circuit analysis such as Kirchhoff's current law and Kirchhoff's voltage law, or KCL and KVL for short, and we will be covering that in future videos.